Yeah, good afternoon, everyone, and happy holidays to our Muslim brothers. I'll try to cover common data models and also try to see this from the perspective of why we need common data models and why uh, we have to discuss those and what are our next session is going to be on ontology development. And so this session would be sort of a bridge between what you've seen last week on common data models, and also it's going to be a bridging to what we are going to discuss in our next session, which is on ontology development, I think, to be presented by uh, Abdullah Kau in one of the next sessions. So we'll try to recap our understanding on common data models and try to grasp its role in data interoperability. We will also explore a little bit about what ontologies are and how they can improve common data model, and also try to look into the different standards that exist and how you would learn and apply those in your ongoing activities on data modeling, data standardization, and verification in general as we move ahead towards creating findable, accessible, interoperable, and reusable data for both machines and human. Because we always need to think about machine readability and machine actionability also at the heart of this. So we saw in our last discussion what common data models are, and we define them as ways of organizing data elements in such a way that they are really harmonized or are common across different could be study areas if you're doing research, or different software systems. For instance, observational medical data is standardized by OMOP CDM, or OMOP common data model, where they try to create similar conceptual schema across different databases where they do observational medical research. And because they have a common data model, it's easy to be able to sort of uh, make the data interoperable. You can merge the data, you can query the data, and you can do additional research. Another common data model, which we can also call it, is in fact its initial idea was for message exchange, was for what we call fast health information exchange, or FHIR. So it's to facilitate data sharing, it's to facilitate integration and also reuse, because if you have a common data model, if you can really you reuse whatever data exists at different places in a sort of similar fashion by bringing them into one database, or they don't necessarily have to come to one database. Whenever you're doing distributed analytics or distributed analysis of the data, they need to have sort of an alignment. Otherwise, you would not be able to make sort of analytics that you would want to do. Why does this matter? Because we can have a cross-system exchange of data, or sometimes called cross-domain interoperability, which enables seamless data flow between different systems. You would also want to do reproducibility or validity of research or validity of a finding that you do in a sort of collaborative research that you also do. And it drives analytics and especially in AI and machine learning. The advanced insights can be done if you have a common data model. When you see it from a health standpoint, if you have a similar way of representing your health information, you could be treated in one hospital, and whenever you are to be treated in another hospital, if it will be easier for the health handling to be similar, so that the information can be exchanged if in a similar fashion, and you should be able to do another thing that is common, especially in health area, in terms of standardization of, for instance, diseases, is for instance, easy and fast handling of insurances and the likes, because different diseases could be called differently in different places. And if you have, we have what we call international classification of disease, for instance, ICD-10 and ICD-11, that makes it possible to have a common understanding of a similar disease across different domains. So this interoperability can be seen at different levels. You would want your at the top level, you would want to have an alignment. You would want to have a syntactic and semantic interoperability. By syntactic interoperability, it means that you created similar syntax across different places, but you can also, if you use ontologies, if you add meaning making into your terminologies, you can make the interoperability to be at a meaning making level, meaning to the terms. You can, even if they are represented differently, for instance, sex and gender, because they mean the same, then you should be able to somehow uh, merge, for instance, or do aggregation of data, or do an average of male and female, or whatever you'd want to do based on their semantic representation. The other thing is you can also have, using just APIs, you can do at a protocol level, using, for instance, an HTTP protocol. Two systems can interact, but it doesn't mean they have a good alignment. Then you'd have to do the logical mapping technically. So the role of this common data model in interoperability is that they create a unified schema where they provide consistent framework for the data, and you'd have a harmonized collection of this data, and this allows us to bridge silo, because different data systems on different data domains would have a similar way of representation of the data that makes it possible to do interoperability of the data. So how do you add semantics to those common data models? Because these common data models could be you have created a similar structure, or you define a data structure, and they don't always may not always define meaning. The fact that you have arranged, for instance, your variables in a similar way, you can think of that as creating a common data model. So when you add ontology or meaning to the terms, and also you create relationship that allow you to make inference among or using those terminologies, then you are adding a semantic layer, or you are adding an ontology to it, and this results in an enriched common data model with concepts from existing ontologies could be reused in creating this common data model, Or if the ontologies don't exist, then you would have to, or if the concepts are not represented in a standard, for instance, and if technology language, or in a certain, if they are not stored in a publicly searchable domain for usability, then you can create your own, put them on somewhere where they are accessible, and then you can enrich your common data models through those semantics or through those ontologies that you have created. So I see a question on the chat that says, what's the difference between vocabularies and ontologies? This is a very good question. Vocabulary is just list of terms. You can have common vocabularies that are created by different communities to create a common data model. Thus, for instance, you can have vocabularies that have meaning. But when we are talking about ontologies, what we have added is a meaning to those vocabularies, and also not only meaning, but also logical relationship. For instance, sets of vocabularies can describe a person. And that person has a relationship with, for instance, it could be a student, uh, and a student is related to a course because a student takes a course, or in like in I think the question is coming from Maxwell. I believe you have an experience on working with databases, right? When you have databases, what you do is you try to identify the key entities or the key concepts that exist in your database. That's your first step. Then you'd have to do a relationship between the different entities that exist. The relationship could have degree of relationship or cardinality. You define those relationships. So whenever you are asking questions or whenever you're making queries, then it would be easier when the right kind of relationship is created among those entities through primary and foreign key relationship, for instance, that would allow you to do queries. In ontology development, you'd also see how those concepts are mapped and how those relationships are created. For instance, in the case of ICD-10, you can have, or in the sort of controlled vocabularies that you've been creating, they're without any relationship among the different concepts. That's going to be simple vocabularies, but not ontologies. What's an ontology? So it's an ontology is knowledge representation and a formal system for knowledge representation. It includes relationships, like what I was trying to say. It entails the concepts, their relationship, and constraints that that apply to those relationship, to those concepts that will help you sort of do inference, sort of do better analysis and querying and interoperability among the data. For instance, in SNOMED City, you can have diseases represented. They can have how one disease is related to another, or how what the cause could be, allowing you for using the knowledge, not only using and reusing the knowledge, but also creating new knowledge through inference as well. That's why we have those knowledge graphs that we will be creating, and we're trying to learn from the different concepts and try to make the data better used. And I think your question came at the right time as we were moving to that area. So ontologies, vocabularies, and taxonomies. So ontology is formal, explicit specification of a conceptualization. whereas vocabularies are list of terms with definitions. They are less formal than ontologies, and the taxonomy is hierarchical classification of terms with simpler relationship among the different terms. So in SNOMED and Obofoundry, you find lots of clinical terminologies for healthcare. In ICD-10, it used to be simple vocabularies. It's not full ontology yet, but it is moving towards ontology. Same is true with Loeng. So when we see at semantic data integration in healthcare and how this ontologies are used, you can see that lots of ontologies are already published in different platforms. For instance, we have ontology lookup services or OLS, which is a repository for biomedical ontologies that provides a common access point for scientific community to access ontology content. For instance, in BioPortal, you can see a comprehensive repository of biomedical ontologies developed by Stanford, but different partners can publish and host their ontologies there. You can use OntoB, which provides linked data server for ontologies, enabling users to browse and query biomedical ontologies with semantic web technologies. We have also linked open vocabularies where a catalog of different reusable vocabularies for semantic web exists. We also have the fairsharing.org, which has also a catalog of data standards and databases. So you can try to, before creating a new one, you have to find the right ontology, which is a first step that you have to do in various platforms, and then you can really reuse that in your healthcare domain or in any domain that you are working on. So what's the criteria for selecting an ontology? The first one is community adaptation. You prioritize ontologies which are widely used and supported by a strong community to ensure broader interoperability and access to sharing knowledge. Because there could be different standards, different communities can be inclined towards different ontologies, and because you would want to reuse data, you need to really select the right one so that you would be in sync, or you have better chance for collaborating with more communities. The other thing is license and openness. Not all ontologies are free because there is a lot of investment, there is a lot of knowledge, and there is a lot of effort in developing those ontologies, and some of them are not fully open. So especially for Africa, I think even and the license and the payments could really be a challenge. So you'd have to choose those that have, for instance, Creative Commons license or open source license, so that you'd have to you have an easy access, and you should also see how frequently it is updated. You need to select those that have active community and that are managed by better and bigger organizations. For instance, ICD-11 is managed by WHO, so you do not see it going away anytime soon. And it is widely adopted in many countries. SNOMED is a very comprehensive one in health domain, but the issue with SNOMED is it's not free. So those are the kinds of things that you'd have to see. An alignment with the CDM domain is also to ensure ontology scope and granularity aligning perfectly with the specific common data model you are working with. And they also have mapping support. Some of them have software systems that make the searching in the mapping easy. For instance, OMOP CDM have different software tools that help you look for the concept that you are looking for, and you can easily find the concept ID, and you can use the concept in your model. So the selection of appropriate ontology is crucial for your success of semantic integration. Uh, the other thing that you need to do is how do you do the mapping into ontologies? You'd have to do the concept mapping. You can utilize URIs identifiers for linking, where you employ URIs as the primary matching scheme to link CDMs. For instance, in some software systems also allow you an easy search. For instance, we were looking on, and some of you who have participated in the training last time, or in one of the trainings, when we are working with SEDAR, it has an automatic searching mechanism when you are creating a metadata template where you can easily attach those concepts to your metadata template. So the NCBO annotator, which is a web service for automatic annotation of text and terms, which I was just mentioning. I think if we have time, we will look at it. We would also see in one of the ongoing trainings that these tools allow you to do the mapping. Portugee is a free and open source ontology editor and framework for building knowledge-based applications. It supports all2 and RDF and is widely used for creating and managing ontologies. We have a specific section, one session, one of the sessions will focus on this one. And we will also look how you would be using those ontologies. We set our workbench in one of the sessions, as well as RedCap also links with BioPortal, and we will see how those linkages or how you do the mapping and annotation of those ontologies to your templates or to your data tools. So what we are doing by doing this ontology mapping is that ontologies should be indexed and are discoverable in registries with unique persistent identifiers, allowing researchers to essentially locate and reference them. This is like think of the IRIs as because they are similar to URL, right? Uniform Resource Identifier. For instance, if I say www.mu.edu.et, and if I put it on my browser, it tells me all the information about Maqala University, because mu.edu.et refers to Maqala University. So what we are trying to do is we are trying to create a unique ID for each of the concepts that we are dealing with, so that we can really pinpoint and locate and for a certain say that this is what I am referring to when I say this, because it has all the definition, the other concepts it relates to, the date in which it is created, and it is in a public space, and it is globally unique. It is persistent, means it's stored somewhere. It could be in a database somewhere in Stanford or in other place. But what matters the most is that it's persistent. Just like the ORCID IDs or the digital object IDs for your articles, they don't change, right? Of course, persistence could mean you cannot be sure how long it would stay persistent, but at least it has stayed. For instance, ORCID has stayed as long as we all knew them, and we hope that they would be supported and would continue to stay. At some point, there could be transfer of ownership, but things like that, we expect them to be persistent. They are globally accessible, and they are unique. That's what we are trying to see, and those must be openly available through standard communication protocols. Whenever you are developing an application, you should be able to do HTTP request, and you should be able to get those codes. They are interoperable because they are using standardized references or ontologies that allow you to read them in a similar way, and they would be reused in sort of um, creating and recreating your own templates or your own ontologies or expanding them. So we can say that the terms themselves should sort of be fair in a way, so that they can be really essential for us to use them. We look at also link data and RDF for semantic interoperability. We sort of represent our data for machine readability in terms of resource description framework or RDF. We represent them in the sort of subject, predicate, and object, where you have a linkage of the different terms, enabling semantic interoperability by formalizing the relationship and meaning. And this RDF allows us the machines to understand the process and processing of the data in different sources, fostering the semantic interoperability beyond simple data exchange. Because when you have created the right model and the right linkage, and also when you are representing your subject, your predicate, and your object in the form of a URI, the mapping can easily be done. And with the right inference, then you can they would make a graph, or sort of a knowledge graph, leading to a new inference. For instance, I am from Tigray, and Tigray is in Ethiopia. So then the data might not exist in the database as clearly stating that I am an Ethiopian, but you can really infer from the subject predicate object linkage that I am an Ethiopian. So that's the sorts of linked data where you're trying to create the linkage at a data level and understand. So there are, for those of you who might not know what health level 7 or HL7 standard is a very common data exchange standard with FIRE, meaning fast healthcare interoperability resource, which creates a sort of common data model and also a messaging standard that can be accessed through RESTful APIs, representing patient observations and conditions in a sort of a standard database, if you call it, or normally what we call it is a profile. You have a profile or representation of what your healthcare data looks like. So if you have similar profile for on how you, for instance, define a patient. A patient can have a name, ID, age, gender, those kinds of attributes, and they are represented in a similar way, each of them having their own unique IRI. Then you can really exchange data in faster. They can really be interoperable. Think of it like if you had similar variables across different research groups, making it possible for you um, to do the mapping and the data exchange easy. Beyond just mappings, they also provide technological tools, implementations. For instance, Fire has what we call Happy Fire, which has a full-fledged software system, having its own database, having its own APIs that makes it possible to read and exchange messages across. I think in the interest of time, I'll try to be faster to allow also for our next presentation. We also have a similar concepts or similar way of representing in OMOP common data model, which uses standard concepts. Each concept has a concept ID, and the observational medical outcome partnership common data model transforms disparate healthcare data into a standard format using common vocabularies like SNOMED, which is included in that database creation, allowing for different data to be represented in a common way. The systems enable you to do sort of analytics and visualization because they are basically represented in a similar way. Another advantage that you get is when you're doing data queries, for instance, if it is represented in the form of knowledge graph, whenever you do Sparkwell queries, your query would be based on those terminologies or based on those vocabularies that you've created during your ontology developments, allowing you to create semantic queries that can really fetch data from different places that have similar meanings. So you're trying to connect diverse domains. You're trying to integrate. It can be different. It could be cross-domain that will allow you to do the queries by creating the right amount of alignment between the different terms. So what are the challenges? The challenge is that you could have overlapping standards because you have different organizations or different ontologies created and vocabularies created here and there, and choosing the right one could be or choosing the right level of granularity because you can have concepts, sub-concepts, and the different level of granularity could be sometimes confusing, and that the governance and curation of the different systems could also be an issue, and learning and understanding this whole process is also not an easy thing because you have lots of knowledge areas and lots of technical things and non-technical things that you need to cover here and there. So the best practice normally is that before you start creating your own ontologies, you need to reuse existing ontologies. You need to follow or established community conventions for consistency. You need to provide a clear mapping between different terms and document all those practices. You also have different metadata standards that are very common that you be using in in your developments. And there are also different platforms that allow you to, for instance, a fair data point enables your data and metadata to sort of be discoverable and accessible. We'll also be, as we move ahead, looking into different tools that you see here in using and reusing those ontologies and terms that we create along the process. So I think I can stop here, considering the time. If you have any questions, feel free to ask. Otherwise, thank you very much for watching.